Hello again. Since this course is called Physical Hazards Controls, we're going to get started now with some controls. All right, we're going to talk about controls. That's the meat and potatoes of this thing, and everything else kind of hinges on control. What controls we're going to use? We got a hazard here. We got something that's dangerous to our people. So what are we going to use to control it? Now let's take a look at this. This little thing here. This thing here is called the hierarchy of controls. Now you'll see different ones out there. This is the one that's been around, I think, the longest, and I think is the best one. That's the one I'm going to use. And I use this in every course I teach, I think, because it's just a good thing to know. And you should, as a safety professional, you should have this down pretty pat. You should know what this does. As you can see at the top and on the left, there's a bar that says the most effective down to the least effective. So we start with the most effective thing. You got something that comes into your company, a new whatever process, machine. Maybe you bought a new company, who knows? And you got a hazard. So you want to do something about that hazard. You want to control the hazard. So the best way to do it is eliminate it. Just get rid of it. All right, we don't need this. We're not going to do this anymore. That's not always feasible. That's more feasible in a design stage. We might be able to do that, but it's already here. We already got it. We probably not do it. Okay, can we substitute something for it? Something that's less hazardous, a less hazardous chemical, for example, or maybe even less exposure to it might help too. So that's something we could do. And I mean less time or something like that. I don't mean protective clothing is type of exposure, but so substitute something less hazardous for that. That's hard to do. That's usually done with chemicals. We had Southern California had a wash station, a parts wash in the shop. It was a tray, and there was a little kind of like a little sink, and we washed parts in there. And the company that did this came out every month and changed the solvent in there, and they went to a less hazardous solvent. It wasn't an oil-based solvent anymore. So I don't know what it was, to be honest with you, but it was less hazardous. That's why they did it. They replaced the hazard. Engineering controls. Engineering controls isolate people from the hazard. When somebody says engineering controls, you want to think isolate people from the hazard. That's what an engineering controls does. Engineering controls. And we'll talk about each of these in more depth as we go. Mostly, if you want to think engineering controls, you're mostly thinking guards. Why is a guard good? Because it's there. You go to work, somebody goes to work, employee goes to work on this piece of equipment. There's guards there. Can they be bypassed? Well, anything can be bypassed, come on, but not without some really good effort. And probably breaking some regulations or some company policies too. And then you have administrative controls. The administrative controls change the way people work. So they're not dealing with the thing itself. They're dealing with the people. So now how do we change the way people work? Well, one of the ways is training. And we do a lot of that. So in safety, that's a very important foundation of safety, one of the foundations of it, because you can't always engineer everything out. So administrative controls. And then the last line of defense is PPE, protect the worker with personal protective equipment. Now, sometimes that's the only thing you can do, but but you should have at least mentally gone through each one of these things and to ascertain that one of the higher, most effective things can't be done before you resort to PPE. We'll go into more detail in each one of these here. But you should know this hierarchy of controls by heart. And you're going to hear it a lot. So control methods at the top of the graphic are potentially more effective and protective than those at the bottom, okay? Following this hierarchy normally leads to the implementation of inherently safer systems where the risk of illness or injury has been substantially reduced. So elimination and substitution. Let's go talk about them for a minute. Again, elimination, physically remove the hazard. Substitution, replace the hazard. So physically remove the hazard, just stop doing it altogether. Bam, it's gone. Great. Maybe you moved it to a safer area. Maybe you bought that part from somebody else instead of you making that part. Let's put it to a different building or something like that, or even a different height or different on the mezzanine or something like that. Or you contract that out to specialists like electricians or construction type of thing. So that's, maybe your people aren't that good of electricians and you're worried about them getting hurt. So you call in specialists and let them do it. And you, of course, you vet them and make sure they know what they're doing. But so then we got substitution, replace the hazard. That's use less hazardous chemical material. That's usually chemicals, replacing lead-based paint, for example, or clean with water spray instead of chemicals. So those are easier to do the earliest in the stage of development of this, of whatever it is you're dealing with here. In design stages, more once you've got it, it's kind of hard to do these, but they are there. So most effective, of course, the most effective, you just got rid of it basically. The most difficult to implement in an existing process where major changes in equipment procedures may be required. If the process is still in the design or development stage, elimination and substitution of hazards may be inexpensive and simple to implement. The next step down is engineering controls. Isolate people from the hazard. They're the next logical step. So the nice thing about engineering controls is they are independent of worker interactions. In other words, the worker doesn't have to do anything. They're there. The engineering controls are there. The guards are there. The two-handed controls are there. All the other things, they're there. So the worker doesn't have to do anything to have those engineering controls be there and be effective. And they are difficult, or they should be difficult to bypass or nullify. Can somebody remove a guard? Oh, of course you can. I mean, you have to, guards do get removed for maintenance, stuff like that, but it should be difficult to do. And there should be some, not just, there should be procedures against it too, and it'll only allow certain people to do it under certain conditions. So removing a guard should be a serious thing and well thought out before it's done. And engineering controls can be expensive initially, but they usually last a long time. I mean, they usually last for the life of the machinery. They don't, as a rule, engineering controls don't move. So like a guard doesn't move, it really doesn't have anything to wear it out. So again, but they can be expensive initially, but they last a long time and they're there. The worker doesn't have to commit, oh, I forgot to do this or I forgot to do it. No, they're there. Machine guarding is probably the most common engineering control. That's my favorite too. Used made a lot of machine, had a lot of machine guards made. They enclose the hazard. They enclose the hazards. This is the type of machine guarding. Control rooms or people away from they put in it. Interlocks on machine door guards. These are great, but they can be bypassed. We had a guy got hurt on a piece of equipment that had a door on it, and had on the side of the door had a micro switch. When you open that door, that micro switch opened up or closed on and shut off the machine. Sounds pretty good, right? Well, what they did was they took the door off the hinges on the other side and left these two pieces, the magnet and the micro switch connected, and kind of pushed it to the side. And guess what? They reached inside and got hurt. So they can be bypassed, and that should but they're usually not easy to bypass. Now, that was pretty easy to bypass, shouldn't have been. And that was a new piece of equipment too. Work platforms instead of ladders. That's a good idea. Ladders are inherently are less safe than just a platform you can work on. Two-handed controls, so you have to have both your hands away from the point of operation. That's a good one too. Then we get down to administrative controls. Now they're going to change the way people work. So they don't deal with the equipment. I mean, how do you train a piece of equipment? You don't. So the people, you can be changed. And this is important, very important step. And you almost always have some kind of administrative controls throughout your company or throughout your production facility, probably. They're relatively inexpensive to establish. I mean, somebody's got to figure out how to do it, how to implement it, that type of thing. But generally, there's not a lot of capital expense for administrative control. Somebody writes a policy and somebody gets trained. But they can be costly to sustain because you have to train people to do it. So, and require staff to implement and keep updated too. And they include employee training, like a shadow or buddy system for training, training on job hazard analysis, JHAs or JSAs, hazard awareness training. There should be, you're always going to have training, but and part of their training should be, of course, safety, a big part of it. But employee training is one of the biggest administrative controls. You could do less exposure, like job rotation or work rest cycles. Job rotation is a good one. I like that when you're using different muscles and for the morning or in the afternoon. At OK Foods in the kill plant, they had an inspector and a trimmer, I think they were called, on a platform. And as the birds came by, and one of them had to look down into it and that's, awkward posture and all that stuff. And so, but every break time, about every 2 hours, they switch jobs. So if they work 2 hours on one job and then 2 hours on another, 2 hours. So that was a good job rotation. And they were adjustable too. The stands were adjustable. So if you had a tall person or a short person working both sides, they could switch, adjust their workstations. And again, it was great. We never had any issues or ergonomic issues otherwise with those people in those jobs. Written policies, job descriptions can help so people know what to do and what to do. JHAs again, lockout, tagout, and other policies are all administrative controls. Warning signs, labels, and alarms are administrative controls. I've seen the hierarchy controls with an area in there between administrative and engineering called warnings, but I think warnings are just another administrative control. So, but labels, alarms, you can have, if you have danger or signs up, that tell you not done on it and this or whatever. But they're also administrative controls. And the last one is PPE, protect the worker with personal protective equipment. It's the last line of defense. Now, sometimes it's included along with other controls, sometimes it's all by itself. They're usually pretty inexpensive to establish. Most PPE isn't too expensive. The program must be sustained, though. If you have hard hats, you have to make sure you have them. If you have safety shoes, you have to make sure people go get them, get fitted for them, wear them, and everything else. And they're generally less effective than other methods. And here's the worst part about PPE. It requires significant effort by the affected workers. They can not wear them. Hearing protection. It was a big issue at OK Foods, people not wearing their hearing protection. They could fail to put on whatever it is, welding jackets. And in California, we made some big changes to one of the plants, moved some equipment over and made some significant changes to the building and everything. And one of them was going to put in a new personnel door. So one day there was a little loading dock out there, not a very big one, and the general contractor and I were standing out there, and these two dudes came up to put that door in, and one of them had the hard hat. And you know how hard hats are. The webbing, it keeps the hard hat away from your head. So if something hits your head, helmet, it doesn't hit your head. Well, he had the webbing cut out of his, so it was sitting down on his head because that looked cooler. I'm sure that's why he did it. And so they were walking up there, and the general contractor said to him, "Hey, bud, what's the matter with your hard hat? Your hard hat's not running right." Well, we had hard hats. If the guy would have been a decent about, we're just giving him a hard hat to wear. It wasn't a big deal. But he copped an attitude. Says, "Oh, it broke this morning." Well, I got news for you. It didn't break this morning. Hard hats don't break like that. He just cut him out to it looked cooler. And so, but he copped an attitude with the general contractor. The general contractor threw him out. "Get out of here. You're off. You're out of here. You're off. Either one of you guys, get out of here." Here they had a truck. They had all their stuff there and everything else. Well, 2 minutes later, general contractor's phone rang, and it's this guy's boss. "Oh, please let him back in." Like, money. Nope. This guy's never commented on my job site or any job that I'm on with an attitude like that about safety. And that's the kind of attitude a general contractor should have. So PPE includes hard hats, eye protection, safety, shoes, gloves, welding helmets and goggles, and all that welding apparatus you wear, respirators, hazmat suits. There's a lot of stuff in PPE. And again, you got to wear it. We had a guy at OK Foods dropped a canister on broke his toe. When I looked into it, I found out that he was wearing tennis shoes, but he had a pair of safety shoes that the company bought him that was at his home. So I made sure that he got written up for that. And his boss didn't want to run him out because he was a good guy. But I said, I don't care if he's a good guy or not. We paid for his foot protection, and he didn't have it on. So that's the downfall there of this guy. Even though we recognized the need for PPE and bought it for him, he didn't wear it. So controls, if the hazard cannot be eliminated, which most won't be able to, the adopted control measures will likely be a combination of any or all of the three items instituted simultaneously. Now, for instance, PPE, hearing protections, PPE, right? But you have to train for it. So there's training involved there. So you kind of doing administrative controls there, training. And so a lot of times there's a combination of them. So briefly, again, controls do this. Elimination, physically remove the hazard. This is right off that triangle I showed you. Substitution, replace the hazard. Engineering, isolate people from the hazard. Administrative, change the way people work. PPE, personal protective equipment, protect the worker from the hazard. So, and again, engineering controls, well-designed engineering controls can be highly effective in protecting workers and will typically be independent of worker interactions. In other words, they're there all the time and they work. So they typically do not interfere with worker productivity or personal comfort and make the work easier to perform rather than more difficult. Again, people can talk about it. They don't want to wear this suit because it's hot out. They don't want to wear a protective suit, or they'll come up with all kinds of reasons not to wear PPE. But if it's an engineering control, it's there. Administrative controls, one of the most common is in training. And again, that has to be done. Although it's common sense to train anybody before asking them to do something, OSHA makes a lot of training mandatory. And so should your company. Every company should have a lot of training. It's kind of that old adage, you can pay me now or pay me later. You can train somebody now, you can pay them to pay that time it takes to train them now, or you can pay their hospital bills later on. Most OSHA regulations are administrative controls because most OSHA regulations change the way people work. Personal protective equipment consists of, again, hearing protection, eye protection, respirators, hard hats, shoes, safety shoes, and protective clothing. And it's acceptable as control in the following circumstances: when engineering controls aren't feasible or do not totally eliminate the hazard, while engineering controls are being developed, maybe, when safe work practices do not provide sufficient protection, and during emergencies when engineering controls may not be feasible. So PPE does not eliminate the hazard. Just remember that. Again, you are going to see this triangle many, many times in probably all the courses that I teach, because I'm a firm believer in it, and I'm a firm believer that you ought to know it. And so the hierarchy of controls is an excellent tool to use, especially when something new is introduced or you are new to a situation too. You need to know how to use it. So here's a very possible scenario in your future as a safety professional. The company you work for brings something in. Maybe it's a piece of equipment, maybe it's a whole new facility, who knows? But it's brought into your company. Now, how do you address the hazards involved? People are going to look at you and say, what are we supposed to do? Are you going to go, hem on the horn? No, you're not going to hem and haw. You're going to say, okay, let's get down a hierarchy of controls. Can we eliminate it? Can we substitute something? No, engineering. And I want you to look good, of course, but that's not the reason. The reason for it is you're going to use a scientific approach to the most effective control down to the least effective control and try to get something in there. So I know this is an online class, there's no discussions, but what he had in a machine, you look around, it has exposed belts and pulleys. So what kind of control do you use? Well, you can't just get rid of it, right? Or substitute something, but can you put an engineering control into place? Of course you can. What would you do? You'd put a guard on it and make sure when you have a belts and pulleys, and they're very common in the industry, when you put a guard on it, it also fits on the machine side and not the away side, so you can't reach around that guard into it. There's a real simple rule of machine guarding. I've used it all the time, and you can use it too. That's really, really simple. If something is within 7 feet of the floor or work surface, you can touch it and it can hurt you. It should be guarded. Pretty simple. Okay, here's another one. Equipment's very noisy. All right, we'll talk about this later, but let's just say, you and I are standing 3 feet apart and we can't hardly carry on a conversation. There's something wrong there. Now, your first thing might be a hearing protection. But I've had this happen again. That same company where we moved that equipment over I was talking about before, that one piece of equipment was particularly noisy, and so it was old equipment, and it was surrounded by a guard or kind of a cage around it, which serves as a guard of expanded metal. So we got some of that egg carton looking stuff, that sound that knocks the sound down, and put it inside that cage. And not 100% of places, but in place where we could, and it knocked the sound down. And then we also in the same company actually, we had a piece of equipment, a picker, which has a big drum that spins and tears stuff apart, scrap, so we can put it back into production. This is a very dangerous, heavy piece of equipment, and you could stand beside it and you could hear yourself think. So what we did, we took that thing, we did 3 things for it. Number one, we took it apart and had it balanced. That big heavy thing, we had that balanced. Then they replaced the bearings in it on both sides, new bearings. And I think most importantly, this was a cast iron base, had 4 big legs on it. And we put some sound deadening equipment between the legs and the concrete floor. you'll find that that is a really good way to cut down on noise on a piece of equipment. And when we did all three things, boy, you could stand by that thing. You wouldn't even hardly know it was running. So there were some engineering controls. We got a couple cases to get rid of noisy equipment. It's possible. Now here's a maintenance employee had a fingertip amputated by a chain and sprocket. Now, what kind of controls can you put in place here? Well, it depends on what details were. What happened? Was he working on a piece of equipment when somebody turned it on? Then in that case, guess what? That's probably a lockout problem, and that's an administrative control. Did he stick his finger somewhere it didn't belong? It could be a training issue. You have to kind of know a little bit more what went on. Sometimes maintenance employees, remember the machines they're working on, have the guards off because they're working on them. But when the guards are off, they should be locked out. But so depends on what the details were. But it's more than likely it's an administrative controls of lockout in this case. So that's it for controls. Now these are controls you're going to have. We're going to talk about these controls throughout the course because that's what this is called. And again, the vast majority of controls, we talk about administrative controls and training and OSHA regulations because you couldn't, this would be I don't know how you could talk for 16 weeks on just machine guarding. So we're going to talk about physical hazard controls and a lot of things that are, you're not going to find out anywhere else. I don't know about any safety program almost, because you're going to get exposed here instead of just a textbook somebody wrote. You're going to be exposed to the actual laws you're going to have to deal with on a daily basis. So I suggest when you do that, when you get an assignment or when you look in your instructor's comments and that says read 1910.147, read it. I'm going to talk about it. Yeah, I'm going to do that a little bit too. And we're going to be some questions about it, maybe some assignments on it, but read it. I know it's hard reading. I know that, but do it because remember, these OSHA regulations you're going to be using for your entire career. So you ought to get to know them. You ought to be conversant in them. All right. All right. That's it for this one. Everybody be safe.